Test, test, test.
Yes. Yeah. I suggest to have this way, or there is an error here. You should see this.
Right now it's just the pink.
To mirror the. La coda era partita là, no? No, non ho fatto niente. No, quello penso Lorenzo. Chiedi a Lorenzo, Luigi.
It was a little quicker. So we actually got some good time. So you have those backup slides and you want to have our conversation and be valuable. Sure.
Okay, so you have the remote queue and the list of participants on me.
And the red button.
Yes, the red button. Where is the red button?
I think it's behind my laptop.
Okay.
We can move it around.
Sì. Magic red button to grant, to unmute,
Okay.
mute,
So just
or
alternates.
grant, yeah, or grant the next
Okay.
in the queue. Okay.
When
You grant, you will hear the remote participant, and if they enable their video, you will see it in this interface and will be projected.
And when I so I grant them the mic, they speak. When I take them off, do they get removed from the queue then?
Exactly.
Okay.
Yeah.
So they can go back. In
Yes.
the queue if they have another.
Perfect.
That's awesome.
Got it.
Thank you. Thank you.
Thank you.
Hello, everyone. We're going to get started just a few minutes late to give a few extra minutes to people that might be out at lunch. But I'm going to start passing around the blue sheets. So if you would, sign and pass. So we're going to get started in a minute. I just want to see if anybody here, I know John has agreed to take notes. Thank you very much, John. If anyone else wants to take notes and collaborate with John, I would appreciate that. If you want to stick your hand up, I'll give you credit for it. If you want to just do it and sync up later, that's fine too. So thank you for that. Is anybody here, I'm going to try to monitor Jabber for the remote participants. Is anybody here also able to do that? No hands. Okay, well, there's a handful of people in the Jabber room right now, so I will watch for them. By the way, for remote participants, we also have this Meet Echo thing going on with a virtual remote queue. So if you're in Meet Echo, I'm also monitoring that. And I will get started in just one more minute. All right, it's about 5 after, so I'm going to get started. Welcome to the NVO3 Working Group meeting. The blue sheets are out there, I think maybe a couple rows back. Please be sure to sign in so we can figure out how many people are here, etc. As you can see, my co-chair was not able to make it in person. I do see that he's on the Meet Echo, so that's good if he wants to speak up. Unfortunately, so hi Matthew, and unfortunately Sam is not able to be here. So I'm all by myself up here in this giant room. So first of all, please note well, this is an IETF meeting, and therefore all of the IETF rules apply. In particular, there's some IPR rules and things like that that you should know about and care about. If you have questions, I would be glad to answer them later, but the gist of it is that anything you do here is a contribution to the IETF, anything that you present or say. So please keep that in mind. As I said, the blue sheets are going around. John is taking notes. I am monitoring Jabber and Meet Echo. So anyone that wants to contribute to any of the things I just said, taking notes, looking at Jabber, etc., please do so. Of course, you know how to join the mailing list, or you probably wouldn't be here. As I said, we're monitoring Meet Echo. I've got this clever little Pac-Man outline thing with a microphone, which you can see mirrored on the screen over on what I think is your far left. So if people want to speak up remotely, I'm going to treat the virtual queue as if it were an in-room queue at a mic, and sort of, you know, who's there first, try to manage that. Of course, I'm only human, so we'll see how well I do. But please be aware that people in the room and people remote are going to be potentially queuing up at their respective mics. Just a quick look at the milestones slide. This is literally the same slide I presented a handful of months ago in Yokohama. We haven't really done much since then in terms of milestones, but it is sort of obvious that these are all outdated. So Matthew and I have talked about what to do here. We've talked with Aaliyah. We're trying to figure out how to get the work done, get the working group to move on. And so we'll probably go through and update dates on some of these things to be actual real dates instead of last year. Haven't actually worked out the details of that yet, but it will be happening. The intent has not changed. We want to close out the working group's work probably this year. So keep that in mind, and in the next couple of slides, keep it in mind because we have some work still to do. Broadly speaking, tried to look at all the stuff that's going on and break it down into a couple of categories. We've made a fair amount of progress on data planes. If you look at quantity as progress, we have 3 of them. On the other hand, for instance, in the control plane, we haven't actually had what I think to be very much good discussion or consensus building around the, oh, by the way, I see that Margaret is in the Jabber room. Thank you, Margaret. What I was saying, we don't have a lot of discussion around control plane. I think there are a couple of drafts out there and there have been presentations, but we need more discussion on that. If there's an interest for the working group to do some control plane work, we need to do it quickly. If not, we'll move on. Either is an okay answer, but it's up to the working group to decide. We do have some drafts, and you'll see a presentation today on a VXLAN Yang model. Frankly, we need to talk about Yang and models in a broader context around the NVE abstractly, multi-protocol, and accommodate OAM functions and all of this. So there's some work to be done there. It should be work that we can achieve. We've got a good start, and we want to start to organize that now. There is the last point on here, the OAM design team is going to give a presentation today. Eric will be speaking on this, and I think that'll help kind of bring some of these things together. A quick update here, and I got this slide from Yushao, and I think that maybe Pat might have something to say about this. I don't want to take words from her mouth though, so let me see if I can get this squarely on the screen.
Yeah, so Yizhao, stand up so they can see you, is editor, co-editor for the draft in 802.1 for the VDP extension to support this, but we need participation. And we're going to try and handle it so we do allow for as much participation as possible without being physically present. So we'll be having an interim in May, and at the interim, I expect we will, we're trying to arrange to have online participation for that part of our meeting. And there's a presentation up with a proposal for TLV formats. And there's a doodle poll that was sent out, I believe, to the NVO3 working group list as well as to the 802.1 working group list for people to select times to be available for a bi-weekly, semi-weekly conference calls on this. So please respond to the poll. Yizhao and I will be available after the meeting if we want to just have a little bit of talk about organizing the work, but basically it's not going to happen if there isn't participation.
Thanks, Pat. And Yizhao and Pat, if you want to send that message again to the list, I know I saw it, but just to remind everyone that might be hearing this right now, sometime soon, that'd be great. Thank you. So if you recall, a couple of slides ago, I talked about the fact that that our milestones need to be updated with dates that are in the future as opposed to the past. One of the things that Matthew and I have been talking about doing is putting together an interoperability thread of meetings. We have to figure out a lot of the logistics around this still. But at the end of this thread of meetings, we anticipate having an interop demo somewhere that hopefully gets some good exposure for those of you that have implementations of this. We're in conversations with the Linux Foundation, who is now organizing the Open Networking Summit, ONS. We may be able to do it there in March 2017, and that seems to be, I think, a nice carrot for people to work together in the meantime to demonstrate some interoperability in things like the data plane, control plane, and OAM, and whatever else you guys think we need to demonstrate. So so we're considering putting this thread of meetings together, but we need feedback and, frankly, volunteers, people that want to be involved both in the administrative side of setting up these meetings and organizing them, also, more importantly, frankly, people with implementations that actually want to bring them to these meetings. And I know there are some implementations that should be easy, i.e. software implementations, and some which might be, let's say, a little more expensive, like big boxes that have hardware implementations and so on. So we may need to figure out how to balance all of that out over time. Anybody who has opinions or willingness to help, please let me know today or send an email to Matthew and I, whatever's convenient. We want your help. The goal, just to kind of bring this back to the milestones, the goal here would be that in basically the remainder of this year, that we will get through these interop meetings where we'll have some work done on identifying who has implementations, how they work, and possibly gaps that we need to document. Get all of that done, close the working group at the end of this year because we have successfully achieved our milestones, hopefully, and then have this demonstration at the beginning of next year in about a year's time from now, as a way of sort of celebrating the interoperable implementations. So with that, I'm going to jump in quickly. The agenda today, it's fortunately just a handful of items, and we'll work through them. We do have a little extra time, so any kind of questions and conversation within reason is welcome. And with that, I'm going to pass the mic to our first presenter, Eric. Let me figure out how to get your slides up.
Is this turned on? Yeah. Maybe I need to pick it up. At the last IETF, we started, oops, I can click here, if I can figure out. A design team to look at OEM across the different encapsulations in NVO3. And there was a large number of people that were invited, and the number of people that have participated is actually a lot less. But Deepak, who's actually been leading this stuff, he actually put together some slides that I edited a bit to give an overview of where we're at. And there's some questions for the working group, and in particular for the different encapsulations at the end of these slides. But if you have questions and sort of concerns around OEM in general, we can talk about that now as well, since we have some extra time actually.
Hey, Eric.
Yes.
I can't hear you very well. I don't know if they can, maybe a little higher.
Can you guys, oh wait, is it, have to do the rock singer thing, okay. Tell me if it gets too loud. We looked at, there was a fair bit of discussions with weekly phone calls, and we looked at, started looking at deployment scenarios and use cases, and looked at things that are a bit broader than we might have traditionally thought about in the context of NVO3. And the different OEM proposals, or the different pieces, bits that are defined here and there. We also talked some about use cases for some marking bit in the packet format, and we'll cover a bit about the questions here as well in terms of encapsulation. One thing to keep in mind is that there's actually another design team operating in parallel, which is a routing area design team that Aliyah chartered, and there's a few of us that actually are in both of these ones. So sometimes I'm very confused which meeting I'm in and exactly what we're covering, but some of these things around marking in particular, there's more discussion elsewhere. So I think that there's some I don't recall if there's actually a presentation about the marking in the routing area working group meeting. There might, Aliyah seemed to be nodding, but that talks more about what you would do with this stuff. Some of this stuff has been discussed in the past in NVO3 as well, back in Honolulu or somewhere. But so if we look at the type of things that we covered, what you think about on the left side of this slide is something that might be more central to what we've been doing with data centers in NVO3, right? But Igna's actually brought up lots of good points about, well, if we're doing this stuff, we might be running NVO3 in the data center, and it's actually is inner working with some other technology that's happening in the service provider network, L3 VPN, whatever, right? There's a ton of different technologies there that all have slightly different OEM, and maybe we should think about how do those things actually connect together from an OEM perspective? You know, interworking of the different OEM schemes, and is this a pure overlay there as opposed to an inner working function in the data plane, and then how do you interwork the OEM? So those are some things that we actually covered in the discussion, and there's, as far as I know, there's no sort of drafts that have started exploring this part of the space yet, but it seems like it's a useful thing to think about. So if you look at this sort of picture of the different interconnectivity and where NVO3 applies, and also where then OEM applies, you can think of many different cases. So one of them is within one of these data center bubbles, right? So nothing particularly new there. The other thing that we of course get is that we have this north-south communication going out on the internet, So in that case, NVO3 terminates in some gateway of some form towards the internet. And well, to what extent can you actually do OEM, sort of IP OEM, be it BFD, ping traceroute type thing that transcends, that sort of spans across the data center network as well as the rest of the internet? That's one of the questions. The other one that's interesting is there's two ways these different bubbles are interconnected. One is this thing called a Dci Gateway. And there's sort of qualitatively different things you can think about. One is if I have these two data centers and I own some set of connectivity that I control that I interconnect them. It's potentially different than the black arrow on top where it's just saying, well, I interconnect them over the internet, right? And I don't necessarily control all of the devices. I don't necessarily know about the topology and resources, etc. in that, following that black arrow going through the internet core. But when I interconnect them using this Dci Gateway, I do. So the considerations for OEM might actually be different as a result. Right? In one case, you can actually have stronger knowledge about topology and resources for that interconnection, which actually matters if you want to be able to do things like explore all ECMP paths. Well, if it's the internet core, how do you know how many ECMP paths you have? You don't, right? It might vary. So there's some open questions in general about, which ties into what I just mentioned, that to what extent do we know about the underlay, right? In some cases we do because we control it. The same operator owns the underlay. In other cases, you're running on top of something that you don't know about. To what extent do you know anything about how much nested tunnels do you actually get in the core? Different administrative boundaries in these topologies. Right? And one of the key things for the working group, and I'll talk more about this at the end, is basically getting semantically equivalent support from the different encapsulations. Right? The encoding doesn't have to be the same, but actually having the same, and you might have subsets of functionality. I don't think that we have to mandate that all encapsulations should support all the same OEM, but we don't necessarily want different flavors of the same thing because that just gets confusing for the users and it makes it harder to work things. So these pieces can be optional, but having sort of common definitions of them seem to make sense, right? Make lives easier, make people's lives easier down the road, particularly in terms of teaching operational people about how they should use this to operate the network. I think that's the main thing. The other thing is that people haven't looked at in detail, as far as I know, is so how would this inner work or relate to SFC OEM? In some cases, NVO3 is used as a transport for SFC, and how do those play together? So there is some more work to be done there, definitely. I think we just started scratching the surface here, both on the sort of working side with different data planes, existing ones, as well as the SFC one. So one piece that came up, and please, I'm not going to go into the motivation in any detail, but I don't have slides on them, but the discussion we had back in Honolulu was around having marking for some way of synchronizing counters so you can actually try to measure packet drops by being able to use a marking bit in the data plane, and that causes effectively some synchronization, some switching of different banks of counters. Details can be done slightly differently, but the notion of having such a bit seems to be something that people think are interesting. This is something that, if we're going to do this, I think it's important to get it right and sort of not have different definitions of it, because people will need to build this stuff into hardware for it to be useful in hardware NVEs, right? Question at the mic.
Greg Mirsky, Ericsson. If it's possible, why would not allocate 2 bits to be able to use full potential of their marking method? So
you're saying that the current proposal for doing marking needs 2 bits? I think that's
Yes,
being
I can
discussed.
refer to the draft in Beer Working Group on passive measurement with a marking method, and will be discussed in the Beer Working Group this week. And so there are two bits. One bit is to create batches of packets, and then and the second bit is to create marked bits that can be more accurately used for more accurate latency and variation measurement. Because with one bit, you can effectively do good loss measurement, but time metrics measurement would not be that accurate. With 2 bits, you have very powerful mechanism. And there will be a more extensive discussion of the marking method in general and all the recent modifications on Friday morning in IPPM working group as well. So everybody is welcome.
Okay, so yeah, it sounds like we should. My suggestion is that people that are interested in the stuff follow this other work, whether in IPPM and elsewhere, right, to see whether we as a working group want to follow that. I don't think we need to define our own here, but right. And I think, and I sort of recommend that people get involved in this if they care. And I think one of the things we need to make sure is this is whatever people are proposing, and that it's feasible to implement in the sort of hardware that people might think they want to implement it. Software we know is typically doable, but yes.
Stuart Bryan asks from the Java room, why do you need 2 bits? Surely you only need 1 to create the batches.
Greg Mirsky Erickson. Yes, you can create batches with 1 bit, but second bit creates a marked packet in a batch that you can track to do latency, packet latency, and inter-packet delay variation calculation. So with 1 bit, you can do probably latency, but you cannot really reliably calculate jitter.
1 bit is, very sensitive to packet drop. So if you drop 1 packet, you cannot measure the delay. Right.
But again, we have probably about half an hour at IPPM working group for marking method discussion. So anybody who stays on Friday, welcome.
Yep, that sounds like a good idea. I think that at least my higher bit, and the thing that we've talked about in the design team is we have 3 different header formats here. We should make them have the same, we should define the same capabilities, and then whether people implement it or not is a separate matter, but at least define it once somehow. So there's a large number of pieces of OEM functionality that we might want here, and some of the things that are new from this perspective when we look at the way NVO3 is deployed is due to ECMP, right? That we have potentially overlay ECMP, which we already know how to deal with because that's what IP does. But we're combining that with some underlay ECMP in terms of how these things are transported. And there's that coupled with sort of being able to understand something about the paths and failures. We know how to do traceroute in an IP network. Well, here we have an IP network on top of an IP network. What does it mean to traceroute all the possible paths across the 2 layers of ECMP and find out failures, right? I think that there's things here that are different than what people have done before. And it's not always the case that people want to expose all of that underlay information to the tenants running in the overlay, but if they do, right, how do these things actually get exposed? So a fair bit of these things are not specific to NVO3, and that's why I think that the sort of tie-in when the routing area overlay OEM design team is important as well. One thing that might be useful for people that have NVE, NVA implementations, if they have sort of already done thoughts on what they're logging or what they're tracing, right? it would be useful to figure out how to fold that in, because I think what we've thought about mostly in the design team so far is around the sort of more classical OEM pieces, but implementations might already have sort of logging unusual events or whatever that we can try to capture and see whether we have commonality for that. In the OEM headers, I think all of the 3 NCAPs that we have in NVO3 have something that is an OEM bit or a control bit. Don't remember, these are not my slides, but I did edit them this morning. There are some questions, particularly around fragmentation, where it's sort of existing deployed protocols like VXLAN, they tend to skip on fragmentation because you don't want to do that in hardware, etc. Right? And there's some, I think we're carrying that forward for some of the existing proposals in NVO3 as well. If that's the case, at least you need to be able to discover when something is messed up in terms of your MTU, right? Because packets would actually just get dropped on the floor somewhere. So I think that's what this fragmentation in red refers to. Yes?
Yeah. Actually, I apologize, a little bit belated question. So the proposal, I understand, is to identify OEM payload with a bit in the header, not with a protocol type.
Yeah, that's the way the current NVO3 encapsulations are defined.
Right. So would that create additional ambiguity? So how to interpret protocol field if you have OEM bit set?
So I actually I put this question on the last slide, but there is a question about do you want to have. So I think that the way people have been thinking about this in NVO3 is having this OEM bit means that you can sort of make the initial part of the header look like a regular inner payload, and then you have some additional OEM information in the packet somewhere. And hence, sort of following the pattern that's there in Trill OEM, but I don't know if people have thought of it that way, but and then you need a different bit. But if it's really saying, well, I'm just going to send this packet and the payload itself is OEM because it's a trace message, it would be sufficient to have a separate payload type as long as that doesn't affect the ECMP behavior, the hashing behavior going through the network.
Right. So I think that's exactly the question is if the payload information not being used by this layer for the forwarding, then protocol type probably can be an option, and then this bit can be reused for something else.
Yeah, I think that's a discussion that we should have, right? But it ties in with these assumptions about what do we think, in particular, underlay devices will actually look like for their hashing, right? If they're going to look at, if this is carried over UDP, you have a UDP header with IP addresses, a source port. If it's V6, you might have a flow ID. You have a bunch of things you can use for hashing. Are they also going to say, we're going to add value by looking inside the inner payload or the payload type, whatever? Then it's more talk.
Alternatively, there might be another option is to include in NVO3 header entropy information that can be an expression on entropy of the payload, and then used by their forwarding, and not then you don't need to look into the payload.
Yeah, but we at some level we already have a few bits. We have 14 bits of that in the UDP source port, right?
Right.
So if you need more, okay.
Yeah, I agree. So then basically why consider that somebody is doing layer violation and looks in the payload?
Because you always do that. Okay. No, I think it's a very good question. I think it's a key question for the working group, right? Saying, are we going to say, if you want to be able to send OEM frames on the same paths as regular data frames, are we going to say in that case, you must not actually do your ECMP lag hashing too deep into the packet, right?
I think that there might be one option or one way of characterizing it is that saying, okay, we propose do this, but if you choose not to do that, you will lose fate sharing in band OAM.
Yeah, okay, that's...
Tom Herbert. So I actually had two comments. One is related to that.
Can you move closer to the mic or speak closer?
So we have both the UDP source port and also the IPv6 flow label. What I kind of would like to see is some guidelines, basically, especially with regards to the IPv6 flow label. So if you're doing ECMP, just look at the IP header, and then we can consistently route any packet, regardless of protocol, encapsulation, or anything like that, and still route based on the flow. So this would work not just for OAM, but for ICMP, for instance, if I wanted to produce a ICMP echo to follow the same path as a TCP packet. In the flow label world, I could do this as long as I don't have devices trying to be smart and parse into the next layer. So comment number two, though, I'm wondering about this restriction or idea that we're only allowed to use 1 or 2 bits out of the encapsulation header. If I remember correctly, the 3 encapsulation protocols that this working group has taken up are actually extensible, which means we can define OAM fields or OAM information. So for instance, if I wanted to get latency, one way I could do that is put a timestamp in a packet, send it, expect the destination to reflect my timestamp, and then I get a normal TCP-like round trip time. So this would work in, I think, all the cases you mentioned, except for VXLAN, obviously, which has no capability for that.
Yeah, VXLAN doesn't have extensibility. I think that the flexibility of extensibility with GPE is also more limited in that you would need to insert an extra header with this in the case of GPE, right? There aren't any sort of variable length options or anything else in GPE, right?
Greg Mirsky Erickson. So you get round trip with this method, and because the forward will be over your layer network and return will be over out-of-band network, I think dividing by 2 would not give you really characteristic of your overlay network. So you need to have uniquely one-way measurement because dividing by 2 doesn't work.
Well, right.
It's
I mean,
too raw.
but that's what we have now, and that's what everything is based on. If my user says they have a latency problem, they don't mean one-way latency. They mean when they send a reply and they get a response, right, but what is that latency? So really, to me, that's what's relevant.
No, but
round trip latency.
well, if you're measuring in the same network layer, that's probably justified. But if you are measuring if your latency affected by 2 different layers of the network, then okay, you can say, well, that's approximation, that's as good as we can. But I think that we have methods that to do better. I'm not saying that this method is invalid. It's probably good for some scenarios, but I don't think that we can say that that's good enough.
So it sounds like there is a fair bit of discussion around latency and whether this is something that we should figure out how to have a high bandwidth conversation on the side and get together, because there might be different choices there. And I know that, yeah, you can do timestamp. I haven't looked at the details of what they're proposing in VR and IPPM, but.
So I just wanted to point out, latency I was using as an example. And my point was that the amount of information you get out of 2 bits limits you to that amount, right? So in the future, if we want to have more interesting things, like if you wanted to do record route or something more advanced, how would you do that with 2 bits?
Okay, we can discuss this offline.
Yeah.
I can say that, yes, you can do.
Hi, Eric. Sharon, the very Broadcom. I just wanted to see, is it possible for other people to join this design team, your design team?
Yeah, so we're trying to figure this out. So we should talk offline. So But I think that part of the issue is that we haven't had that much active participation. There were lots of names on the first page, but the last few calls, I think we were 3 people there.
I think, yeah, I like
So-
to participate because I have a lot of experience and I implemented in Silicon. So I think I
Okay.
can use my expertise.
That's good.
Okay. Come Thursday to the routing working group. We will continue discussion.
So the font on this is a bit small, but I think the high order question is, is it reasonable for the working group to say that we're going to define OEM that's common for the 3 NCAPs? I'm sure the pieces will be optional, but we're not going to have sort of different variants of doing the same functionality that behaves slightly differently for the different encapsulations. I'm sure the actual where things are placed in packets might differ, right? But not actually have independent, slightly different definitions of what the semantics are of an obit or whatever, or whether it's that or a payload type, OEM payload type, but they're not different. And then I think Greg brought up this other question, which is, do we need a payload type, just a bit, both? There was a question that the design team came up with where it wasn't clear from the document. And exactly, there isn't much text in the various NCAPs about this document. I think that the most succinct text is actually in the Geneva document, right? But like the CBIT and GUI, it says it's a control thing. Well, is that just OEM or could it be other things, right? That's not clear from reading the document. I think the GP document has less detail because it just says, oh, it's the OEM bit, and that's it. I don't think there's any other word about it, but maybe there's a few more. But so there's room for more specificity here. But as we do that, it makes sense having it be common, right? There's a question about whether intermediate underlay nodes can look at the OEM packets traveling in the overlay. Can they participate in that by sort of sending reports, whatever? The wording in the Geneva document doesn't allow this. It's not clear what the right thing to do here. It's sort of the relationship between the overlay and the underlay in general. Are we assuming that all the underlay does is send ICMP errors and we somehow use those? Or are we assuming that they can participate by sending some new OEM, report messages, whatever? None of the documents actually talk about what happens if I get some errors from the underlay, ICMP errors. Can we set the OEM bit on normal payload for in-band OEM, or does it, what's the semantics, right? The GUI spec says the control is control. It doesn't actually carry a regular payload packet, my understanding. Are packets with the OEM bit set always dropped by the destination NVE, or can they actually be forwarded towards the end system? Maybe I'll go through all of these first, and then we can have discussion at the mic. And we already talked about this, no impact on ECMP lag that Geneva makes explicit. We talked about the M bit, and I think that was it. So I was more or less done. Okay, questions, comments?
Tom Herbert again. What would it mean to set the OEM bit on a normal payload? I thought the OEM bit redefined the payload to be something else.
Yeah, and that's part of I don't know if this is the whatever quote unquote trill heritage, but the notion of having an OEM bit that flows with data, and when it comes to decapsulating MVE, it basically says, well, this is an O bit, so I should feed it to the control plane, and it will take it and send back some report, right? Some OEM message back, instead of just decapsulating it and forwarding it to the end system. But otherwise, the packet looks like, it has a TCP header in the inner packet, whatever. And this was something that was required when OEM was defined for Trill, because Trill didn't have sort of an entropy field anywhere. The only way you could do hashing would be to look at, if you weren't satisfied with what's in the outer header, you would have to look at the inner headers, right? So there it was required, but it might not be for these encapsulations we have today.
Okay, so if the OEM bit is set, that is never received as a normal protocol packet on the receiver. Is that correct?
It's not decapsulated and sent to the actual end system,
It's
right?
a separate, goes through a separate receive path.
Yeah, basically says hand this to the OEM process on your box. So next steps for the design team, I think, is to work more closely with the routing area overlay OEM team. And we tried to look a bit at BFD and how it fits in here, but we haven't actually accomplished anything. And then, figure out, should we put together some document at some point in time that covers this stuff with some more concrete things? I think that for many of these things, there's a fair bit of overlap with the routing area overlay OEM team. I'm done.
Okay. Jesse Gross. So I think everyone is definitely in favor of having more commonality for OEM, and certainly no objection there. But I wonder to what extent it's feasible without ending up at the lowest common denominator. I mean, certainly we've seen that already in a couple of discussions as far as being somewhat parsimonious with 1 bit versus 2 bits versus and also whether you have a payload versus you put OEM and some options that would be carried at the same time. So it seems like you're kind of hard.
But I think that, well, there's a question about how many bits you would sort of need, right, to reserve, and there might be limitations in some of the encapsulations. Some of the other things, I think what's most important is actually the semantics. So if one encapsulation says, I can do this with an OEM bit, and another one says, I'll do this with a payload type, but the semantics of them are identical, I think we're fine, right? Because it's the semantics that affect what people can do operationally as they go use these tools. So right.
Yeah. No, I mean, clearly, if we can match the semantics and that gets everything we want, then that's great. But I think I certainly agree that there's probably more uses for OEM that you can fit in 1 or 2 bits.
Oh, sure, and I'm sure that we will see different implementation, even if we have one spec, right? We will see different implementations that implement different subsets of it as well, right?
This is Dino. I don't think you need any bits in any headers if you just make the internal packet address to the endpoint, the VTEP itself. So if you originate an IP packet and you're the destination VTEP, I'm just going to send a packet to you. I'm going to encapsulate it in whatever outer header is there. You're going to decapsulate and you're going to deliver it to yourself, which is going to be the control plane. Then you can put anything you want. You can design any protocol you want on the inner, be it an IP packet that's addressed to you or a MAC frame that's addressed to you, and you don't care what the outer encapsulation is.
Yeah, so maybe there's one piece missing from the puzzle, which I didn't talk about sort of what we're trying to solve, but one of the things that people have pointed out is sort of the ability to piggyback OEM on existing packets that flow through, so that if I have data traffic for this VPN or this tenant, I can actually perform some form of measurements on that without having to inject additional measurement packets.
Yeah,
and for instance, measuring, that's where the measuring drop and delay comes from, right? And
But you're going to find that there's going to be either silent sources or you want to check the path before you use it. So that's reasons to have more control planes sort of thing.
yes.
Okay.
I think both correct. One method doesn't give you complete ability to do OEM. So you need combination of passive and active. Okay, and passive means that you do not modify packet so that it changes how the packet treated by the network. Because there, for example, there are proposal that you can add extra header in IPv6. That would not be really passive method because you change the length of the packet, so thus the treatment by the network changes and the performance metrics will change, right? So that's why there is proposal, as we formulated in a beer, that you have 2 bits that should not be used for the forwarding decision, okay? Thus, you can use them, but you can monitor them and changes in the values as a marking combinations signifying the end of the batch and their bits, the packets that you select for measurement. But at the same time, yes, you're absolutely right. If you want, for example, monitor standby paths, you need active methods because you don't have traffic there. If you have not sufficient load on a network, you might not really, you need to create some active traffic test probes. When you are turning the service on, you can use active performance measurement to do service activation protocol, right? So I think that, and that's what we discuss in our sessions, that combination of passive and active OAM methods give you the most powerful tools.
So
I would argue active is a superset of passive, and passive is more complicated than you need.
So we're up against our time limit here. I know there's a jabber comment we'll take at the mic, and then Eric can have the final word.
Yeah, I got a comment from Stuart Bryan. I asked him for some clarification, which might be forthcoming, but he said true, but that is what I have asked. But you need to give the lower layer a hit to do real-time OAM. Also true, to go loss, you really need to instrument the packets.
Maybe get loss.
Measure loss, yeah.
I'm thinking to get loss, but I haven't gotten a clarification from him.
I assume that to measure loss, right? Yeah. Okay. No,
Agrees with Greg.
on that, we're out of time. Okay, that's good.
Okay, so Eric, you get the last word?
No, that's good.
All right, thank you, guys. Measure loss. All right.
Yeah, doing active measurements to measure loss might be quite expensive because you might need to send 1 million packets to find out that you have 10 to the minus 5 packet loss, right? That's a bit expensive. But if those packets are already flowing, it's sort of get it for free, quote unquote.
So thank you for everyone for talking about this. I know we have a schedule to keep here, but let's keep the conversation going. And next is Fang Wei Hu, and I have a clicker if you want to use it.
Okay. Okay. This is Fang Wei Hu from ZTE. So I will present a Vexnan protocol young data model. Oh, this is the second time to present this draft. Yeah. So I think Vexnan access type is the most important node. So I described here in details. We defined 5 types for the Vexnan access type. One is VLAN 1 corner 1 and VLAN N corner 1, VLAN L2 interface and L3 interface and MAC address. For the second one, VLAN N corner 1, we think that here should greater or equal to 2. So I will describe this 5 types one by one. So here is the VLAN 1 corner 1. We have 2 VTAP 1 and VTAP 2. We also have WinID 1010 and WinID 1030. So for the VTAP 1, we have VLAN 100 and VLAN 300. For the port 1 and port 2, these 2 ports belong to VLAN 100. And for the VTAP 2, we also have VLAN 200 and VLAN 300. Port 1 and port 3 belong to VLAN 200. Port 4 and port 5 belong to VLAN 300. So for this VLAN 1 corner 1 type, we can have the mapping of VLAN and VNID. For VTAP 1, we have VLAN 100 mappings to VNID 1010. For VLAN 300, it will be mapped to VNID 1030. For VTAP 2, VLAN 200 maps to WIN ID 1010, VLAN 300 maps to WIN ID 1030. Okay. So for this type, we can say that the WLAN ID of V type 1 and V type 2 mapping to the same WIN ID can be different. Here we can say that for the WIN ID 1010, for the V type 1, the WIN ID can be 100, but for V type 2, the WIN ID is 200. So next is the VLAN N-1. So for the V type 1, we have VLAN 100 and VLAN 200 maps to WIN ID 1010, and VLAN 300 and VLAN 400 maps to WIN ID 1030. For V type 2, VLAN 100 and VLAN 200 maps to WIN ID 1010, and VLAN 300 and VLAN 400 maps to WIN ID 1030. So for this type, we think that for the same WIN ID 1010, the WIN ID of V type 1 and V type 2 should be the same. So we can say that the VLAN 100 and VLAN 200 should be mapped to WIN ID 1010 in the both sides. So next is the VLAN L2 interface. And for this mapping, the port number should be added for the mapping key. Here VLAN 100 plus port 1 will be mapping to WIN ID 1010. For V type 2, VLAN 200 plus port 1 will be mapped to WIN ID 1010. So this is the VLAN L2 interface. Next is L3 interface. This is simple because we use the L3 interface. So here for port 1, for interface 1, we have address 1.1.1.1 and 24. So here we just map interface 1 to WIN ID 1010, and for type 2, we also have the interface 1 map to WIN ID 1010. So next is the MAC type. And this is also very simple type. So for the MAC 1, 2C-33 7A587561 will map to WIN ID 1010. So what is the difference of VLAN 1.1 and VLAN N.1? For VLAN 1.1, the WIN ID mapping to V type 1 and the remote V type 2 can be different for with non-WIN ID. We have the example in the previous slides. But for VLAN N.1, the WIN ID mapping to V type 1 and the remote V type 2 must be same for with non-WIN ID. And the second difference is that the process for the inner tag handle model. For VLAN 1.1, the inner tag handle model can be discussed in the VLAN model and no discussed in the VLAN model. But for VLAN N.1, the inner tag handle model must be non-discussed in the VLAN model, because if it configured as the discussed in the VLAN model, the data transfer to the remote V type 2, the V type 2 doesn't know how to transfer this packet to the destination host. And next is VLAN corner 1, and is the difference of VLAN corner 1 and VLAN L2 interface. For VLAN 1 corner 1, the VN ID can be mapped to several ports. We can say port 1 and port 2 belong to VLAN 100. So this VLAN 100 maps to VN ID 1010. But for VLAN L2 interface, the VXLAN VN ID only maps to one port. For type 1, VLAN 100 and plus port 1 will be mapped to VN ID 1010. But VLAN 100 plus port 2 will mapped to VN ID 1020. So this is another VN ID. So this is the VXLAN access type. We have three value for this node. Next is the VXLAN access type configuration. So we have a VXLAN instance, and the K is VXLAN ID. So VXLAN ID is to identify the VXLAN. And the next node is the VXLAN access types. We just talk about this node. Next, we define the VXLAN control plane. So we have three different control planes for in our data model. First is PIM-SS plus data plane linear, and the second we can configure the static tunnel, and the third one is UVPM protocol used as a controller plane for VXLAN. Okay, question?
Yes, hi. Sharon, the very Broadcom. I thought this is you're going to describe a Yang model. You just changed the VXLAN paradigm. I mean, where is the L2 and L3 interface in VXLAN? This is your own invention?
Sorry, can you?
I said, you talked about 1-to-1, N-to-1, I don't know, L2. So where did you get all the 1-to-1 and N-to-1? Okay, that's okay. But where did you get this L2 interface, L3 interface? Is that from any RFC, from any draft? No, previous.
So you mean?
No, the L2 where is, L2 interface. Next one. Yeah. Where did you find this? Yes.
You mean?
Did you invent this, or is this from an RFC?
So for VLAN L2 interface, we can configure in the interface venue.
But there is no standard for this.
So I will took you offline.
No, it's not offline. You're just inventing stuff here. This is not. You cannot do this. Nobody can do this. Why do you need a model for something that nobody can do?
So,
No, you have to write a model for an RFC. You cannot just model whatever you like to model.
So I will discuss it with you later. Okay, sorry.
Okay, but I don't agree with this draft.
Yeah, it's quite common for the VLAN mapping potentially to be set up fairly dynamically. You know, if you're using the VNID, it may be very local to a given port, and because there's not very many VLAN IDs, so the the VLAN IDs may have to be allocated kind of as the VN IDs are moved to certain ports, and then that's set up as a local mapping to between the ends of a split NVE when you come in. So this makes it seem like it's more static than the mapping of the VLAN ID to VN IDs than I think it should be. I mean, the VN IDs are the thing that's really saying that this is this particular network, and the VLAN IDs are potentially just a marker for where you don't have the VN ID on the packet to say this really belongs in this network because I assigned it that way when I set up this connection. When I used VDP, for instance, to say I wanted to have this VN ID on this port.
Yeah, here we define the VXLAN access type. So, for example, for this finger, so if we define VLAN 100, if we define the VXLAN access type for V type 1 is VLAN 1:1. Yeah. So for the port 1, because port 1 belong to VLAN 100, and the VN ID can be learning from PIM-SM plus data plan or other, or by the EVPN. So I think the mapping of VLAN 100 and the VN ID can be achieved by the control plane. So if VN ID move to another port, if the VLAN access type is the same, so they will have another mapping. So I think this is no relation with the distribution of VN ID. Yeah.
Yeah, I'm just concerned that this seems to kind of make it seem like it's a static, that this
Yeah, here VXLAN access type is the parameter for the V type. So if we configure V type, so if we configure VX, if we create a VXLAN instance, we should configure the VXLAN access type. So.
Yeah, I don't think this works.
Okay, thank you.
So I don't know if this focus on the defining a set of access types is that useful, because I think that in addition to the previous comment that you seem to have access types that aren't actually implemented or defined anywhere, right? They might be useful, but they're not actually standardized anywhere. I think that you're missing some things that are actually in use as well, because existing devices can do a VLAN mapping before they do the VXLAN Encap, for instance, right? It's just an existence proof that you're not covering everything, but you're covering also some things that aren't actually standardized anywhere or used. So I don't know if there's a way of separating this out, basically saying that we have some demarc point between whatever VLAN behavior you have on a device, right? Which there's existing implementations and whatever, and they might be standard for some of these things. And then there's a handoff to VXLAN. And I think that picture is a lot simpler, because I think at that handoff, there's only two behaviors that exist. One is I preserve the inner.1q tag or I strip it, right? I think that those are the only things that differ there. And then the different boxes at the two ends, they can have whatever VLAN port behavior mappings, whatever they want, right? And then you don't have to try to figure out, do I have 2, 7, however many access types do I have? You just end up with that distinction.
So I think if so I can have a global view for our young data model. So here we have a VXLAN, we have a VXLAN container. So there are also VXLAN instance belong to this container, and another we have we have we type instance belong the VXLAN container. So first we will create a VXLAN instance, and we will configure VXLAN access type and WAN ID. So we also create a we type instance. Belong the we type instance, we will configure the inner. We will configure the inner tag handler, and we will bound the we type to a WAN ID. We will have a bounding between VXLAN and VXLAN instance and we type.
So I think it might be sufficient to just have this inner tag handling mode and not worry about the access types in this document, because that allows you to specify how it behaves from a VXLAN perspective. And somebody else would worry somewhere else about how can I define various VLAN behaviors. Right?
So we're up against our time limit here. I know there's one more comment in the back, and then we'll move on.
Okay, this is Diego from Nokia. Yeah, I mean, I agree with some of the comments that it probably means to focus on the attachment of a service to the VXLAN binding, because on the access side attachment, you're defining, certain models. The port significant VLAN can be implemented and is implemented by some vendors. The VLAN-based approach is implemented by other vendors, but you don't also define whether there's qualified learning or unqualified learning. There are a lot of open points which maybe belong to the layer 2 VPN working group or other parts. And I agree with Eric that we should maybe be focusing on the attachment of a service with however we define a service into the VXLAN tunnels, but the access part is probably something that needs to be defined elsewhere or a lot more in detail.
So I think this has been actually a really good conversation. We should carry on to the list. There's been some good feedback, and I think we want to come to a consensus around a working group model for this stuff, VXLAN, VTEPs, and more broadly NVEs. So we're out of time to keep talking about this, but Fangwei, thank you. And to everyone who spoke at the mic, please carry on this conversation after. Okay?
So
do you have a final slide?
Yeah, we have several slides.
I think for the sake of time, we'll need to move to the end. Do you have a final slide?
Okay.
I know you have a lot of more information here than we have time for.
So
no, go to the last slide.
So this is the operational state model. We have a VXLAN instance and we type instance and stack VXLAN tunnel operation. So next comments.
Yeah, thank you. So before we talk about adoption, I think we need to have some more discussion on the mailing list to carry through with some of the things that were talked about here today. But thank you for this talk. Thank you. Tom. Clicker for you.
Okay, my name's Tom Herbert from Facebook, and today I wanted to talk a little bit about Checksum Offload, especially with regards to UDP encapsulation. There's actually been quite a bit of work, at least in the Linux networking stack, to kind of adapt to this world of encapsulation. And in particular, what we're trying to do is preserve all the benefits, the offloads, particularly in performance, that we have in the normal non-encapsulation path with encapsulation. And clearly encapsulation adds some interesting things. Today I'm going to talk about one aspect of this, which is really how we deal with the checksum. And in particular, we think of the checksum not as necessarily just an outer UDP checksum, but really how do we efficiently process, say, an encapsulated checksum in TCP or UDP. So checksum offload is a well-known technique that many NICs, or probably most NICs, provide, where they can perform the checksum calculation on behalf of a host for TCP, UDP, or ICMP, basically any internet one's complement checksum. And NICs have implemented this in two different ways, what we call so-called protocol specific and protocol agnostic. And I'll get a little bit more into the implications of that. Encapsulation is interesting because not only does it move the checksum in deeper inside the packet, for example, TCP checksum becomes encapsulated, we also now have the possibility of more than one checksum per packet. And if you think about this, it's really an unlimited number. We could have 10 levels of encapsulation with 10 different checksums. We have no reason to artificially prohibit this in implementation. So what we're looking for is a generic solution that kind of can deal with even that case in a nice way. One of the goals we do have, though, is no full packet checksum computation on the host, meaning we don't want to go through the host CPU to do a checksum calculation. This is actually a pretty expensive operation. Checksums are obviously well known and simple, but the fact is, if we have to go through a packet to compute a checksum, we have to pull all the bytes into the cache. We have to run through at least an add with carry instruction. So it's not the cheapest thing that we can do. So on transmit, as I mentioned, there's a protocol agnostic, protocol specific one. The protocol agnostic one is called hardware checksum. Basically, this is where we tell a device, here's the starting point to checksum, here's where to write the value, go ahead and do the calculation and write the value. So it doesn't need to know about the protocol. The software will set up the pseudo header checksum in the field, and it's taken care of. So this is a way to basically do a very generic offload of one checksum in a packet. Historically, though, most providers or NIC vendors have provided what we call IP checksum. And this is where the NIC actually parses the packet, figures out it's a TCP IP packet, looks at the pseudo header, calculates that, calculates the checksum of the TCP header and the data, and finally writes the answer into the TCP checksum field. So it's quite a bit of logic. It's not generic. Obviously, though, it's a simple interface from user space or from the kernel. They've been doing that a long time. Similarly, on the receive side, there's this thing we call Checksum Complete, which is where a device just simply provides the checksum calculated over the packet, usually from the start of the IP header. And the idea is that the host stack can use that information. It can subtract off the checksums over various layers to produce checksums of sub portions of the packet. So with one checksum calculation done by the device, we can basically validate any number of checksums, whether encapsulated or not, inside a packet. And conversely, though, to the transmit, there's a protocol-specific version, which is kind of referred to as checksum unnecessary. And this is where the device actually looks into the packet, figures out what the protocol is, performs the checksum calculation, decides if the checksum is valid, if it sums to 0. If it is, it tells the host inside the receive descriptor, I validated a checksum. If it's not, it usually doesn't say anything. So again, this requires a lot of logic in the hardware to parse protocols. We do have some vendors who started to be able to parse into encapsulations in order to validate checksums, which means they now need to be able to parse VXLAN, for instance. Our preference from the software side is really for the protocol agnostic means. If nothing else, this means that we can apply something like Checksum Complete to any protocol we could invent. So if we add a new protocol, for instance, we don't have to go to the hardware vendors and ask them to support it. It's already supported. So anything that has an IP header check or IP checksum, we should be able to support offload using that model. Now in reality though, most NICs that have been deployed have been using protocol-specific mechanisms. Last month at the Linux NetDev conference, we did make a big play and push and are advising all the vendors to switch to protocol-agnostic means. But in the interim, since we have a lot of deployment, we have to consider how to best leverage these protocol-specific kind of devices. So it does turn out, though, that if we play our cards right, that even enabling the outer UDP checksum turns out to be a performance win. And that's, in fact, one of the goals that we have, at least in Linux, is by default, we're going to start, where we actually have started enabling the checksum in UDP encapsulations. So in order to make this reality, we apply various tricks. All except one actually do not involve protocol change, which is kind of nice. Checksum unnecessary conversion kind of sounds like what it is. Basically, if we get a checksum unnecessary indication that an outer UDP header checksum has been validated, we can actually pretty easily convert that into what the checksum calculation is over the UDP payload, and then use that as though it's like a checksum complete that the device gave us. So again, that's doesn't require any protocol change. It's actually fairly simple. One of the other interesting non-protocol mechanisms that somebody observed recently was that if we have a device that does have the capability to offload an inner checksum, say an inner TCP checksum inside UDP, and the UDP encapsulation has the outer checksum enabled, you can actually deduce the value to set in the UDP checksum field on the basis that we know that everything from the TCP header on with the pseudo header, once the checksum is calculated, the answer is basically zero because it will calculate a zero checksum. So we can use that to our advantage and figure out the checksum for UDP is really just based on the UDP header and anything before the TCP header where the TCP checksum starts. So this is great because what it means is with one single offloaded checksum, which is the inner checksum, we're able to deduce any outer checksums, what the value is, without calculating the whole checksum over the whole packet. So again, that prevents us from needing to do that calculation. And a big consequence of this is we don't have to go to hardware vendors and ask them for 2 or 3 or n checksum calculations per packet. We only need one. And so it was a pretty big discovery earlier this year, and I think that we're going to take that a long way. So the one thing that we have done, which is a protocol change, is something called remote checksum offload. And this is really for those devices that on transmit can only calculate the outer UDP checksum. So they don't have the capabilities to either parse the header or they're not doing the hardware checksum that I described earlier. So basically, these are a lot of devices. They can do UDP, TCP, checksum offload for transmit on plain packets, usually no extension headers, no IP options. It's really just a TCP, UDP packet over IP. So what we can do, though, is with a little bit of extra bits in the encapsulation header, we can actually provide information about the inner checksum to the encapsulation layer. And the information we need is basically the starting point for the inner checksum and the offset where it is. So it's kind of the same information that we give in the NetDev hardware checksum. So with that information, what we can do is we set this in the encapsulation. We do a normal checksum offload in UDP, send the packet. So the hardware does UDP checksum offload on transmit. Presumably receiver can offload the received checksum. And then this gets into the encapsulation layer. Now we know that the whole checksum has been validated with the outer UDP checksum. So in order to calculate what the inner checksum should be, we just need to do some math to basically subtract the checksum from the UDP header to the TCP header, for instance, and then adjust the inner TCP checksum. Once we do that, we then let the packet proceed up, do the decapsulation, goes through TCP. Now we have both the updated inner TCP checksum, and we have the checksum value, which we got from the NIC, that was computated over the packet. Now we can validate the TCP checksum without any additional calculation. So this really is a good thing to save cycles on the transmitter, since it didn't have to go through the full packet checksum for the TCP checksum. So the question concerning this was more of a extensibility question, and I posed this on the list about a month ago. Haven't heard any response. But what we did for a receive checksum off or remote checksum offload, we implemented that in GU, which was easy enough, and there is an implementation in VXLAN and a draft. What we did in the implementation was a little bit on the conservative side. Because this was not a standard part of the protocol, we actually have a bit to basically turn it on only by configuration. So right now it's kind of an opt-in thing on configuration. So my question is kind of twofold. So one is we extended VXLAN by allocating a bit from the header. I think it was bit number 10. And then using the low order 8 bits of the virtual networking identifier, which are listed as reserved, to encode the start and the offset. So my question on the list, and I'm hoping to get more feedback, was, is that architecturally the correct thing to do in VXLAN? How do we make this official? Is it enough to have the draft? We really would like to take away the conservative configuration option in the Linux stack and just make this set by default all the time on the receive path. And then I'll have the same questions for VXLAN GPE. As I understand, there is an extensibility model in VXLAN GPE which has more to do with the NSH. I tend to think that might be overkill, but again, I'm looking for input on this. And by the way, we actually do have a VXLAN GPE implementation in Linux that happened, I think, about 2 weeks ago. So it's a good time to start to think how to basically either make common pieces, whether or not these should be common flags, or whether these paths are completely divergent. So right now they're actually sharing some common code. So if we do something for VXLAN, should we do the same thing for VXLAN GPE, for instance? Any VXLAN experts in here? No. Okay, so in lack of input, I think we'll probably just disable the configuration and make it standard. Don't say I didn't ask. Any questions?
So this is Jesse. So, I mean, obviously this is pretty specific to one implementation. I mean, it doesn't apply at all to hardware implementation. It's just not going to work. I mean, like a switching ASIC implementation. And it's currently only implemented in Linux. There's been a ton of other proposals to use existing bits, so I'm not sure how.
So there's GPB, right?
Yeah, I mean, that's kind of, I'm not an author on GP, but that's also somewhat divergent. But I was actually just referring to, I mean, there's a ton of drafts just using bits in the pure, VXLAN header as well.
And so far, people have just been pulling them out of the air.
Right. So, I mean, I think that the general, I mean, obviously VXLAN did not come from this working group. It's not really,
I'm just wondering if there's, I really wanted the input. I mean, it's more of a meta question, granted. So we know VXLAN is out there. We know it's deployed. We want to extend it in a variety of ways, and we're limited in number of bits. So it's a perfect use case of a real protocol. And the interesting thing is, obviously, it's not a working group item, but yet this working group talks about it a lot. So maybe it's just a matter of one at a time and whichever one stick. I know there were 2 bits for the OAM being allocated. And as you said, I don't know if there's been a ton, but we definitely had several proposals.
Yeah, there's a lot.
And we only have, what, 16 bits, or maybe there's a few more. I think there's a pretty large reserve bits. Yeah, but at some point you run out of bits. It seems to me it's a little ad hoc just to be randomly picking up bits. I guess my hope is that at least that part could be at least clarified maybe by the VXLAN guys. So it's nice that we have VXLAN GPE, but obviously we're doing stuff in both of these regardless of even what happens in NVO3.
Yeah, I mean, I think basically VXLAN is kind of, I mean, it is what, I mean, it's not going to be really standardized extended. I mean, there's been proposals, but they're not, yeah, there's proposals.
Yeah, I mean, in one sense it's good. I mean, there is a lot of interesting things coming up. A lot of it sticks, some of it doesn't. I mean, we have to deal with that. But so in this case, I'm kind of hoping that we get at least a clear path for how to extend VXLAN.
Good luck.
So,
Just on the record, that last comment at the mic, we're over time.
okay.
Go ahead, Eric.
So are you proposing a way of actually allocating the bits? I didn't go look at the draft, but, or are you just saying, I need some bits, just like everybody else?
Your question is?
Are you proposing a scheme that we can get some more order in terms of how we pick bits for VXLAN? Or are you just saying, I'm taking this bit? Are you just repeating what everybody else has done? Saying, I'm grabbing these bits?
I think I was just using this as a single point, but obviously it's part of the larger.
Yeah, because I have a draft that picked a bit as well, right? So it's like, yeah, so it sounds like it would be useful to figure out a way of doing a registry, right? But where you can get someone to manage those bits. And that's a bit tricky because there's not an IETF protocol and it's not clear what allocation policies you would have for those bits. Would you require an IETF standard for an extension to protocol that isn't even ours? Yeah, it gets complicated, but it sounds a bit silly for us to sort of figure out, okay, who might have picked bits at the same time, right?
That's a worst case scenario. And it's not just the bits, right? So I also want a data field. And if you look at the VXLAN header, it's kind of interesting because there's reserved bits here, and then down here after the virtual network identifier, there's other reserved bits. So my theory was that the low order bits on the virtual network identifier are less likely to be proactively allocated because it doesn't look like it's part of the rest of the flags. It's kind of interesting. I'm just hoping that, well, I do think we need clarity on this. And then VXLAN GPE is also interesting because some of the extensions that Jesse referred to won't work in VXLAN GPE. The group policy field, whatever that is, that actually overlaps the protocol field that they put in VXLAN GPE. So to get the group policy stuff, we do have to make a different format for VXLAN GPE.
Okay.
Thank you, Tom. And that was our last presentation, and we are a few minutes over time. So, not your fault. But I guess I want to say thank you, everyone. There are a few topics that we had good discussion around, and I look forward to reading mailing list discussion. Oh, yeah. And by the way, anyone that did not sign the blue sheet, please run up here and sign quickly. They made the rounds, but I think some people came and went in between. Thank you. You think that'd be a bad thing? Lucy's?
You were here the week, right?